Hi everyone, this video is the solution to example 2, where we're going to learn about the Mohr circle and how to draw the Mohr circle for the stress state in a square. So the problem is exactly the same as the previous one, so sigma x, sigma y, and tau xy are going to have the exact same values as before, so 80, 35, and minus 30. But now what we need to do is draw the Mohr circle. Now, the first step to draw the Mohr circle is to locate a couple of points that will help us draw the circle. The first point, we call it point A, will have the coordinates sigma x and tau xy, and then point B will have the coordinates sigma y and then minus tau xy. In this particular case, point A will be with coordinates 80 and minus 30, while point B will be with coordinates 35 and then plus 30. So since we have these 2 points, the next thing we need to do is to draw a graph that has in the y-axis the shear stresses tau, and then in the x-axis the axial stresses sigma. So since I know my sigmas will be positive, will be definitely bigger than 0, and then my taus will be between minus 30 and 30, I'm going to draw the axis, so then it's going to be easier for me to situate these points. So this will be 50 and this will be 100. Well, now if we do it in the y direction, this will be the 30 and similar to do the minus 30. So this should be good enough to start plotting my circle. So I know that my first point is at 80 and minus 30. So sigma 80 is here, and then minus 30 for tau is here. So here is my point A. And then point B will be with 35, so that's 35 here in between. And now 35 and 30, it will be here, point B. Now the next thing to do is to connect these 2 lines to find the center of the circle, which is here in the center. And now we need to try to draw a circle as nicely as we can. In this particular case, I'm going to use the shapes here, but it's always a good practice to try to draw it by hand. And now I just have to put it in the right place, which might take a while, but I'll cut the video, so give me a second. And here it is. So now, what the question is asking is, can we use the Mohr circle to calculate the principal stresses, principal planes, and maximum shear stress? If you guys remember, in the previous example, sigma 1 was equal to 95, and this is exactly what we can find where the circle hits the x-axis, so the sigma axis, and here it is exactly 95 means it was a good sketch. Sigma 1 can be obtained straight away like this. And on the other hand, sigma 2 can be obtained on the other side. So it's the minimum principal stress. And in this case was 20. So again, the drawing was very nice. So this is it. Finding sigma 1 and sigma 2 is just finding where the circle hits the x-axis, the sigma axis. If you want to find the maximum shear, is again measured. So if this would be 40, and this would be 40, the maximum shear is measured here at the maximum of the circle. So if we draw a line from there and from there, we can see that the maximum shear here, let's call it tau max, is equal to 37.5. Again, what we were able to calculate in the previous problem. Now the final step is to find the theta of 157.5. But one thing you need to understand in this Mohr circle is that the angle is always multiplied by 2. So if we take the positive axis between C and A, and we start rotating clockwise until we get to the positive axis, this angle here is 2 theta. That, if you remember from the previous exercise, was 307 degrees, and this is how you measure it. Another way you could do this same angle is to measure it in the negative direction, so here in green. So you could say that 2 theta is equal minus 53 degrees, which is the same angle as 307 degrees. So this is it. This is how you draw a Mohr circle. This is how you get the principal stresses, the maximum shear forces, and the angle of rotation to get that principal stresses. So thank you for watching and have a nice day.